Hello, everyone. Can you hear me? Cool. So, thank you. So, let's start with introducing myself. So, I'm Slobodan Stojanović. I'm from Belgrade, Serbia, and I'm CTO and partner in a small Canadian-Serbian company. We are doing different things for different startups and some bigger companies from North America. We are using a lot of JavaScript, but we are also using some other things. And beside that, I'm also organizing JavaScript meetup in Belgrade. Unfortunately, we don't have a conference, but we have a big meetup group. You can follow me on Twitter, and whenever I have some time, I'm playing with some open source things, so you can check that on GitHub. So before we continue, I would like to know something about yourself. So let's start with the easy question. Who is JavaScript developer? I guess everyone. Cool. Who is working with Node.js? Cool. Okay, and did anyone tried some serverless? Okay, cool. Okay, so let's start. I hope I'll be able to explain you what serverless is. So let's start with the explanation why do you need another serverless talk, because most of the conferences today have at least one of them. It's a big buzzword and everything, but I don't know about you, but for example, for me, serverless is really important because in the beginning, I was just like, I don't want to learn one more hype thing and that will not be used after 6 months or so. And then I just tried, and from that moment until today, it's like a year and a half ago, most of the things that I built were on serverless. Not because it's perfect thing, it's not yet, but it's really easy. You just don't need to care about the deployment and many other things, and you can focus just on your work. It's perfect for me for some quick prototypes, but then I can use those prototypes to develop real applications and things like that. We're not using serverless for everything, and you shouldn't use serverless for everything, but there are some certain applications that are perfect for serverless. So let me try to explain that. And here are some things that I'll try to explain today. So first is, what is serverless? Second is serverless only about the functions, or is there something more about it? I'll show how it works. Then I'll show some popular serverless platforms, so you know how you can use it today. I'll show some example with Node.js, because that's something that we want to see, how it works with JavaScript. I'll show how to debug serverless functions. You'll see more about that tomorrow on another talk, but I'll show just the basic things because that's something that is really difficult to people that are just starting with serverless. And finally, I'll tell you when should you use it. So let's start. Okay, so what is serverless? If you try to search the internet, first thing that you'll see is the discussion about the name. And let's just ignore that for now, because everyone is talking that serverless shouldn't be serverless because there are still servers and things like that, but let's ignore that for now. Second thing that you'll see is probably platform as a service. But that really doesn't explain serverless, because many things can be platform as a service. So for example, I don't know, Firebase or Parse or something like that. All of those things are platform as a service, but some of those things are not really serverless. And if you continue searching, you'll see function as a service, which really doesn't explain much, because even Heroku can run your function, and you still need to care about how many servers, actually dynos, do you have on Heroku. So I like explaining things with something simple. And who played with Lego bricks? Cool. So let's try to explain serverless with Lego bricks. So it's like stepping on a Lego brick, obviously. Not really. Sometimes it is, but yeah. So just imagine that we have some kind of server, and our 4x4 Lego brick will be a server. And whenever you want to build some application, how do you do that? So basically, you build some different things. For example, user management. Then you build some other part like I don't know, file storage. Then you build authentication and things like that. Then you build some core feature of your server, of your application. Then you build some other things that you might need or not need or whatever. And in monolith applications, it's like you glue all those things together. And that works fine until people start using your application, and then you need to scale your application. So how do you scale monolith applications? Basically, you just copy everything you have on a separate server, and then if you need to scale it more, you'll copy everything on the separate server again. And that's not that easy because this just assumes that your database and some other things are outside of those servers. And the problem with that is maybe you just need to scale 2 things on your server, and then you still need to copy everything everywhere. So it can be a bit expensive. And also there's another problem. If something fails, it can affect all the application. So it's not really. So there are some things, there are certain ways to solve all those problems. And another buzzword, because why not, is microservices. We all know about microservices, but sometimes it's not that easy to use them. So with microservices, everything should be solved. We still have some kind of server. It can be virtual server or whatever. And then each service should be independent. And basically, if we have 5 different components on actually parts of our application, we should deploy all of them in the separate servers. And scaling should be easy now. If you need more things, you should just be able to add more things. And if you don't use some service, it's easy to just remove it. Or, for example, if something fails, it can be replaced with something else. You have a backup for that. But the problem is you still need to think about the backups in front of all those things, because if, for example, yellow thing fails, you don't have a backup for it. So it's not perfect yet, and it's not that cheap. If you try to explain someone, for example, your client or your boss, that you need dozens of servers before you even got to production, it's not that easy. So there is a way to make microservices cheaper. It's by bundling them together. And basically what you do is, again, put more different things on the same machine. And when you need to scale, finally you can just scale one thing. But again, you need to make it cheaper, you need to bundle more things together. And there are some problems still. If something fails, it can make a problem. But just imagine that we don't need a server component anymore. We don't need 4x4 white piece of Lego. Just imagine that we can deploy all of our parts of the application separately. And then when you need to scale something, it should be really easy. You can just add more and more of them. And if you need to scale more, it's easy. Again, if you don't need something, that's cool. You can just remove it. Also imagine that scaling is automatically done for you. So whenever you need something, it will be automatically added for you. You don't need to do anything for that. And also, it has automatic failover. So imagine that you've lost your orange brick, and it magically just appears again when you need it, or something like that. So even more important thing, just imagine that you don't need to buy the set of Lego bricks in front before you want to build something. Instead, whenever you use some component, you'll pay just for that. And for me, that sounds really great. And we have that basically with serverless. That's serverless. So is anyone watching Doctor Who? No? Cool. But is serverless just about functions and things like that? No. Or since we're in Russia, let's go with niet. So serverless is basically a technology that doesn't cost you anything if you're not using it. So you can have as many services as you want, but if no one is using them, you shouldn't pay. You should pay $0. There are some small fees, for example, for storage and things like that, because if you have huge database and no one is using that at that moment, you still need to pay some fee for storage of all those data. But you're not paying operating fees and things like that, because if you have any kind of server, you're paying for that server even if no one is using it. So idea of serverless is not to pay until someone is using your application. And functions are just a small subset of serverless. There's many other things like storage that works like that. So many of you probably used S3 or something like that, Amazon S3. It's basically a serverless way to manage files because you don't pay for each transaction or things like that. Or you can do the same with databases and many other things, even authentication and things like that. So this talk will mainly focus on serverless functions, but in order to make your application serverless, you need to integrate all of other things that are serverless, because otherwise there's no really point to go serverless. So how does that work? Because we saw Lego bricks, but that really doesn't explain how that really works. First, functions are event-driven. It's like a light bulb. If you want to turn it on, you need some kind of a trigger. When you press it, it will light up. And after some time, you can turn it off. And you can trigger your light with many things like Amazon Alexa, your phone, and some other things, whatever. So you can also have multiple triggers for the same light bulb on one and another part of your room or something like that. And also, serverless is a bit different than light bulb in one way. If you need more light, just imagine that new light bulbs are automatically added, which would be really nice. And also imagine that all the light bulbs will be replaced if they don't work anymore. So our light bulb in this situation is our function, and all the functions are also stateless. You're not able to save any state on the function because it will remember that only while the execution time is still running. And after that, your function will forget everything. You need some external place to store your state and everything like that. Since by default, Lambda function is running for 3 seconds, it's basically like a goldfish. So how that works with the real systems? Just imagine some really simple application when you have one monolith application with some kind of an API that has some kind of sign up, and it has a small email that will be sent to the user whenever someone registers. Of course, we have database to store those users. Whenever you want to sign up, some controller will sign you up, store you to the database, and then send an email, and after that, reply to the server. There are better ways to do that, but if you want to do it really cheap, you'll do something like that. But the problem is, even if your small part fails, for example, sending an email, everything can be affected. In this way, if you structure the application like this, which is not smart, of course, even if just email is not sent, everything will fail because it's a part of the flow. With serverless application, you can do the same, but a bit differently. Now you have some kind of API gateway that is getting your API requests. Then that API gateway will trigger some kind of your function that will just store your user inside the database. And then you can just reply to user that he signed up. So API request is done. And you can have a separate function that will just send an email. And it can be triggered by a database. You don't need to have any other trigger or something like that. And if that fails, it's really not important because your user is signed up and you can have a retry and things like that. And this costs even cheaper than the first thing. So that's how it works in the real thing. But let's try to explain this black box. What's a serverless function? How does that work? Basically, we have that API gateway, and we have some node function. It's called Lambda function in AWS or Azure function or whatever. We'll focus mainly on AWS, but you can use the similar things with other. So on the right side, you can see really simple Node.js function. You just export some handler, and that handler has some kind of event. Then there is some context about your function, how long is it running at that moment, and things like that. And there is some kind of callback. And if you want, whenever you hit your API, some JSON object will be sent from that API gateway to your function. And that will be event. So for example, in this case with the API, it's body and some headers and things like that. And whenever you want to reply, you just send back, using that callback, you just send back some JSON file and that's it. It's really simple. And let's go to a bit more interesting things. So what can you use to deploy your functions? First, you can use Amazon Web Services. There's AWS Lambda. You can use Microsoft Azure. They also have Azure functions. There's also Google Cloud Platform with Cloud Functions, whatever. There's also some others like IBM OpenWhisk and WebTasks. And there's probably even more of them, but most important are those three. And we'll focus on Amazon because I'm using it the most. And for me, it's most reliable one because it has all the different services that are fitting nicely in my serverless applications. So there's that thing called AWS Lambda. And it's really cheap. It costs just 20 cents per 1 million requests. But also first million requests each month are free. So basically, that's almost a million requests to your API. There are some price, of course, for data that you're running through your Lambda functions, but even for that, it's quite cheap. It can run up to 5 minutes. This is important because if you have some long-running tasks, it's not perfect fit for AWS Lambda. You can just choose how big your Lambda will be. If you need bigger RAM memory, you can increase that RAM memory. Of course, that will use more data and you'll pay a bit more. Also, you can write just in temporary folder, so everything else is locked, which is good from one point because you want all of your code to be stateless. And finally, by default, it will scale automatically to handle 1,000 of parallel functions. If you need more than that, you just need to send an email to support, and they will increase the limit. This is the limit mostly because they don't want you to pay too much for example, if you, by mistake, run some events and things like that. So what programming languages do you need to use for serverless applications? It depends on a platform. Let's go quickly through that. You can use Node.js, Python, Java, now C#, any shell script, and any code that you can execute in AWS Lambda. It's almost similar with Azure. So Node.js, C#, F#, Python. There's no just Java. You can even use PHP here. And it's a bit different with Google Cloud Functions because they're working just with JavaScript. And okay, let's see how does it work with Node.js. I would say that it fits really perfectly, and we'll see why. Almost like that. So there are some pros, of course, and some cons. Good things are first, there's a good startup performance. If you want to run Java function, you need more time to for AWS to set up Java environment and run the code and everything. Node.js is really small, so you have the smallest latency at the moment with Node.js functions. You can solve many things with small modules, which is perfect for AWS Lambda because you just want relatively small pieces of code solved with one Lambda function. Node.js has a good performance with low CPU and memory, and we saw that by default we have just 128 megabytes of memory. And it's single-threaded, which is good because you don't have anything else on your Lambda function, and it's easy to learn. So there are some problems, of course, with Node.js. The first problem is async, the most important feature of Node.js. Why is it a problem? Well, because it's still working fine, but since your function is running just one thing, it really doesn't need to be async. And most of the time, people have problems with async functions, for example, with promises, with forgetting to return the promise and things like that. Also, it's made for scalability, and you don't need to scale anything here because Amazon will do that for you. There are small modules, but if you check your node module size, it can grow really, really fast. And also, Node.js is easy to learn, but it's really easy to fuck up. So let's see Hello World with Node.js. If you go to Amazon site, you'll see this. And if you really take a look at that, only those two lines are important. We already saw that there's event, some context, and callback. And if you just want to reply with Hello World, you can just reply with the simple object. And now, if you want to deploy that, you need to create Lambda function, give it some permissions, then zip all your code, including Node modules, upload that to AWS, then create the API gateway. I think you'll see how to do that in the talk tomorrow, and it's not that easy. Then you need to set trigger to tell Lambda function that it can be triggered via that API gateway. And you need to set the permissions for everything. And if you just want to read it, it's like 11 minutes read, which is not perfect. It's like going to Hawaii from Yekaterinburg with low cost with a bunch of layovers, so it's not really comfortable. So can we do something better? Of course, there are some frameworks, or it's more libraries, not that much frameworks, because most of them are helping you to deploy your functions. The most famous one is serverless framework. It's probably responsible because of popularity of serverless, of name of serverless. Then there's other one called Cloudya.js, and we'll talk more about that one. Amazon has its own, so process is that easy that Amazon has its own library for that, to simplify it. It's called serverless application model. And there's a few others like Apex, and all of them are slightly different, but we'll focus on Cloudya.js because I'm a bit involved in Cloudya, and it's not small anymore. It has more than 100,000 downloads. And if we go back to that, going to Hawaii from Yekaterinburg, it's like, if you compare Cloudya with native upload, it's like having a private jet that will take you directly to Hawaii without stops and anything. So Cloudya can help you build event-driven microservices. We'll see more about that. Web APIs, and even chatbots. You can build chatbots for 10 different platforms. Some of the main characteristics for Cloudya are you can deploy and update. So you saw that long list with 11 minutes read. It's all with one command here. You can use standard NPM modules. There's no boilerplate. You don't need to follow some special structure and things like that. And you can manage multiple versions easily. So it should have really flat learning curves, so you should be able to start really quickly. So let's see how fast you can learn and how flat is that learning curve. So to prepare it, you need to install Cloudya. Then you need to set up AWS credentials. That's not really Cloudya thing, that's general thing with AWS. Let's create some folder and enter that folder, then init npm file, and just install Cloudya API Builder, and that's all. When we do that, we can build a simple API. We'll require that Cloudya API Builder make an instance. I just took a few fun facts about JavaScript, nothing special. And if we want to serve something on the API, it works almost the same like Express or something like that. So we'll just have her out and just return all those facts. And in the end, because this is just Node module that Cloudya will fit in your handler function, you just need to export your API. If you deploy that, you need to run Cloudya create. You need to select region. The closest one to Russia is probably EU Central one, which is in Germany. And you should tell Cloudya that your file is called API.js without the extension. When you do that, you'll receive some JSON like this, but I just simplified that. And if you test that, you'll see some of the facts. It's not really facts, it's more code snippets. And if you want to add more things, like more routes, let's just add more of them. For example, if you want to get one fact or random fact, you can just add a bit more code. You can run Cloudya update to update the code. And for example, you can have something like this. If you go to /random, you'll see some fact. If you go to /8, you'll see fact with the ID number 8. And yeah, that's really easy and cool for me. So there are problems with debugging because where is your console log? Because your code is somewhere in the cloud. Basically, Amazon has service for that. It's called CloudWatch. We'll go quickly through this because until you start working with serverless, you really don't need this. It's basically a monitoring service for cloud resources and applications that you're running on AWS. It has a log and things like that. You can use it on the website, or Amazon command line tools and things like that. I prefer command line tools. So if you want to debug something, you can, for example, do this. I didn't change this slide because I need to, special characters are a bit problematic for this. But if we are using log this instead of here, we'll be able just to filter by log this, and then just select Lambda function that we want to trigger, and I'm just querying to get one single thing from because by default it will return the big log, and you can get something like this. So it's not that hard to test, but debugging is not fun, so there should be a better way to do that, and the better way is to write tests and to make your application testable. And how do you test serverless functions? That's a topic for much longer discussion, but basically it's just Node.js function, so you can test it the same way you're testing any Node.js module. And if you need some examples, there's example, for example, in Cloudia Bot Builder, which is testing everything, just all the tests can be run locally. And also there's a thing called AWS X-Ray that allows you to visualize your function and everything that is connected to that function. If you run that on your function, you'll see something like this. You can click on all those circles and see the details and things like that. And there's just a few more things. I will not keep you that long. The easiest way to learn serverless is probably to play with it. There are some books and there are some articles and things like that, so you should try to find some of them, but the easiest way is to try to build something. The funniest way probably to learn serverless is we build a small workshop for that. So you're building serverless function to run the small tank, and we have two teams. So each movement of your tank is just the serverless function that is returning new coordinates and things like that. We are organizing that all around Europe, and so far it was in Belgrade, Barcelona, London, and a few other cities. If someone wants to try to organize it, just make me. Yeah, you should just go and try to play with it. We will not break anything special, I guess. And let's go quickly why is it important. First one is minimal maintenance. You don't need to maintain your servers and things like that. You still need to maintain your code, of course. This is really important because it allows you to build microservices and good code. It forces good code practices. And unlike the other things, it doesn't cost more if you're following those good practices. So everything is free until someone starts to using it. So you can really follow microservices and things like that. So you can build true microservices with it without asking your boss or your client to pay a lot of money to set up the infrastructure. Also, there's automatic scaling and automatic failover. It allows you to focus on the code that you're writing, not the configuration. And yeah, it's easy to deploy. So when should you use serverless? Actually, let's talk about when shouldn't you use serverless. If you're building something real-time with WebSockets, there's a way to do that, but by default, it's not built for that because you don't have server that is active all the time, so you're not able to connect to WebSockets. Or if you need some really low latency applications, of course, we want our APIs to be low latency, but if you need something that is below 100 milliseconds, that needs below 100 milliseconds of response, it's not probably smart to use Lambda because there's some cold starts and things like that. If you need custom server configuration, it's not good for that. If you need compliance, this is strike true because you can use it now with compliance. If you need some long-running tasks, it's not good because there's a 5 minutes limit. Or if you need some really complex computing, it's probably not a good use case. There are some things that Lambdas are really good for example, web APIs. You can use it as a backend for single-page apps. You can use it for chatbots. You can do quickly prototypes without the big problems in the code, so you can turn that into real solutions. You can process files or any kind of data easily without having the big infrastructure. You can use it for Internet of Things and microservices and many other things. And finally, let's see what the fuck is a problem with the name, because serverless It's like there's no servers, and most of the time there are servers. So, you know, less is more. Most of the time I say that serverless is more servers. It's yeah. So, thank you. Wait for it. So, someone said that serverless should be named just Jeff or something like that because we're talking about the name, not the technology itself. But probably the best explanation is by my friend Gojko Adžić, and it's serverless is without servers the same way wireless is without wires, because you're using Wi-Fi without wires, but in the end there are some wires somewhere, but you don't care about them, and that's something that is important. And just a short summary, serverless is a technology that costs you nothing if no one is using it. It's more than just the functions. It's fully managed. Functions are event-driven. Many things can trigger it. It has auto-scaling and auto-failover, and it works nice with Node.js. Of course, for debugging, just write tests. It's much better. And also, of course, servers still exist, but you don't care about them, so that's okay. And basically, that's it. Thank you. So, are there any questions? Yep. Who's the first one? Okay.
Hello, thank you for your talk. And a really simple question. What do you mean by compliance? When you need compliance, we can't use serverless. What exactly do you mean?
So for example, if you want to integrate payments without using Stripe or something like that, you need PCI compliance. Or if you want to build some medical application, for example, for US, you need HIPAA compliance, and each country have a separate set of rules. And now they enabled, you can build medical applications for North America and Europe. I'm not sure how that works with Russia, but actually, yeah.
Actually, we have problems with this one. In Russia, it's called 272 FZ.
Okay. So, another question?
1, 2. Okay. I had some experience with Google Cloud Functions, and I want to ask about AWS. Do you need AWS handles many files normally and require in Node.js? Because, for example, in Google Cloud Function, you must have only one index.js file and one package.json. That's all what you can deploy to the server. So what about AWS? You can have a large structure?
Yes. Basically, you can, because I think when you deploy on Google Cloud Functions, Google will run npm install for you, right? Right. And it's different on AWS because you need to run npm install and just upload the final package, so you can do basically whatever you want. Sometimes I'm doing, so I did something for conversion of audio files, and I packed the binary application with my code and uploaded that, and it really doesn't care about that.
And second question, sorry.
Sure.
How do you manage roads, like domain and some paths to some function? Because, for example, in Google Cloud Functions, you do not have this routing system by default. So yes. It's some different service.
So basically, here, routes are managed. Whenever you receive the event from API Gateway, you receive some routing. Part of that event is your route. And then we have a small routing library in Cloudia API Builder that will just call the rest of your code and your handlers and everything else. So it's really simple router in your Cloud Function that will just use the route from received from API Gateway and invoke something else.
So, but API Gateway is a different service?
Yes.
It's not built in AWS?
No, you're not able to. It's a part of AWS, but it's not the part of AWS Lambda. So one thing is API Gateway, and the second thing is AWS Lambda. You need both things if you want to use Web API. If you want to use, for example, files or something like that, you can use S3 and AWS Lambda. Then you don't need API Gateway.
Okay, thank you.
No. Any other questions?
Yeah,
okay, up there.
Thanks for your brilliant talk, for those GIFs in particular. I'd like to ask you about this. You explained that it is extremely easy to start developing our applications with those serverless lambdas. and it looks like a case for, say, a new pet project, like something you play with in your spare weekend, and then you return to your real work. Do you have any examples of successful migrations or,
Yes.
well, like full-fledged applications that run using those lambdas?
Yeah, and I'll use this for small marketing, sorry. We're just finishing some book about serverless, and it's going through all the process, how to build a big application and how to migrate your existing application to serverless. So there are some things inside that book. It should be ready in next 2-3 months. But before that, so basically, you can deploy your Express function fully on with Cloudia to AWS Lambda. It has just a small reverse proxy that will just pass everything to your Express function. It has almost no additional latency. But for other things, you can start with some small service in your application. For example, we used it to replace some file processing. For example, we need to process PDF files and to convert them to images. We are using AWS Lambda for that. Or one other use case is a service called mindmap.com. It's doing mind maps, so you can connect different things and things like that. And they replaced whole API for saving everything and for converting files, login, and everything else with AWS Lambdas. You don't need to have one function. You can have many functions with some separate service for login, again, in Amazon, but there's a lot of things you can do. So you can start with some smaller things and then end up with having most of your application running in serverless way.
Yeah, got you. And I'd like to ask one more question, like a practical one. You know that in real applications, we spend some time doing, well, some startup tasks like connecting to database, reading configs, doing some expensive computations in the start, caching, like to have the ability to serve API requests in a quick, low latency fashion. You said that Lambdas should be low latency, but how can we do those computations, those initializing tasks in the first place?
Whenever
using
you
Lambdas?
deploy, there is some things, for example, in Cloudia, we created some things called post-install steps. Whenever you deploy it, you can run different things that will just empty your database or do some things like that. But you can just have a separate function that will do everything for you. Whenever you upload a new version, it can just automatically trigger another function that will do that for you or whatever. Right now, you don't have one big application anymore. You have many small applications, so it's not. You need to develop your application a bit differently. You need to develop everything with event-driven in mind. So it's a bit different, but yeah, you can do all those things.
Okay, thanks.
Okay. Okay, one more question, and I'm not sure if I'll be available after that, so feel free to ask me.
Okay, are there any price comparisons between, say, the same application hosted
On Microsoft and
No. Via the traditional microservice
Yes.
approach and serverless for different scales?
Yes.
It is obvious that for small scale serverless
Yes.
should be cheaper, but for medium and large.
Yes, so for example, MindMap that I mentioned was on Heroku before, and now it costs I think $20 a month for 5-6 million active users each month, so it's pretty cheap. And it's probably not the best example, but yeah, it should be cheaper. It depends what are you doing in your application. It can be expensive for some use cases. Okay, we can continue discussion after. One more question, okay?
My question is, if you have API under authorization, what is the pattern you're using? You are using some token or some other way?
You can. Basically, you can build your own structure for that, but there's even better way to do that. It's called Amazon Cognito, which allows you to have your users in Amazon, and which will just use authentication header, authorization header with some token, JVT token, and authorize everything, and just pass you the data about that user. It's really simple. Okay, that's it. Thank you very much, and if anyone has more questions, feel free to ask me.